Hello everyone, and welcome to the Smart Garden project. The purpose of this project is to automate the irrigation in gardens according to environmental parameters. Also, it allows the user to visualize the data collected by the sensors for its plants and to control the irrigation. In this overview, we can see that the environmental parameters are checked by some sensors located in different gardens for different plants. These gardens have different users which can control and monitor only their own. All the data received by these sensors are collected in the database, and accordingly to their values, the strategies produce an estimation for the duration and the delay of the irrigation for a specific plant. When the irrigation strategy is started, it uses the value of the duration of each plant. Let's have a look at the general overview for the user interaction. We use the Freeboard for real-time monitoring, ThinkSpeak for a total history visualization of the data, the Telegram bot to check the status about the garden, and the Qt interface to add plants and devices to the database. Here we have a complete visualization of the back end of the project. On the left of this diagram, we find control strategies, which manage parameters such as humidity, temperature, or light, and according to their values, an estimation of duration and delay for the irrigation strategy is evaluated. On the left, we have the sensors, which publish new values every minute. Then we have the Telegram bot, the catalog, the Qt interface, the Freeboard, and the ThinkSpeak adapter, but we will discuss these later. This is the general workflow for a strategy. It consists in asking the catalog about the hours of irrigation for a specific plant. This happens 5 minutes before the scheduled irrigation, where environmental parameters are retrieved by ThinkSpeak, and accordingly to those, duration and delay are modified. All changes are posted on the dynamic catalog. Along with humidity or light strategies, we have a time one. Its job is to check every week all the irrigation hours of the previous one, to compute a mini irrigation hour for both morning and afternoon, and finally to post the changes on the static catalog. The irrigation strategy asks the catalog VRS the hours of irrigation for a specific plant. It gets the time of irrigation and also checks the dynamic catalog for any modified values of duration or delay. The irrigator, according to values of duration and delay, decides when and how long it should irrigate the plant. In case the irrigation needs to be anticipated, the change is posted on the catalog for the following day. All these scripts that we see here in the complete structure are all independent and so can run on different devices which communicate via REST and MQTT. In a possible scenario, all sensor scripts which need a GPIO interface can run on a Raspberry Pi. Here we show few sensors connected to the interface and then connected to the Raspberry Pi. All those scripts which are not those to collect data from the sensors can be run on normal computers. Let's have a look to the two versions of the catalog. On the left, we have the static catalog, which stores permanent information such as the name of the gardens, the ID of the monitored plants, the name of the authorized users, the default values for duration, and the unit measures for the different environmental parameters. The dynamic one collects the modified parameters that can change dynamically according to the strategies and information about which sensors are actually active. Let's have a demo of how the sensor scripts work together. On a first computer, we run the catalog script and the ThinkSpeak adapter script. On a second computer, we run the scripts of the sensors, such as the rain sensor, the humidity temperature sensor, and the light sensor. The dynamic catalog has the registration of all these devices with their relative timestamp. Going back to the first computer, we see the catalog script dealing with all the GET requests from the microservices, and the ThinkSpeak adapter collecting, aggregating, and publishing data on the ThinkSpeak website. These sensor scripts keep on publishing values every minute. This process goes on and on until we run the scripts. We ran only device 6, 4 and 5. There's no trace of device 7. In fact, if we refresh the page, after 5 minutes of inactivity, the device has been cancelled from the dynamic catalog. In this demo, we will see how a automatic irrigation happens. We are currently running the humidity control script, the wind control script, the irrigation control script, and the irrigator. As we can see from the dynamic catalog, the irrigation scheduled for 7 p.m. is going to have a default duration of 600 seconds. On the dynamic catalog, no parameters has been evaluated, so the duration and delay is set to 0. Here we are 5 minutes before the irrigation. Humidity and wind control strategies check the environmental parameters and compute an extra duration of 129 seconds plus 270 seconds, for a total of 399 seconds. This value will be reported on the dynamic catalog for the irrigation of 7 p.m. Now, let's fast forward to the irrigation time, which is scheduled to be at 7 p.m. If we look on ThingSpeak on the left, we see the blue bar which symbolizes the irrigation. If we look instead on the irrigator script, we see that a value of 999 seconds has been published. If we go back to the static catalog, we will see that the default values, such as the duration of 600 seconds, hasn't been changed. Let's see Freeboard. After we run the script, we are able to see the data that we have on ThingSpeak in a different way. The data on the left are coherent with those on the right on ThingSpeak, and this is just a different way to show them. Thanks to the Qt interface, we are able to easily add new gardens, plants, and devices to our pre-existing garden. Now we try to add the demo IoT garden, and we will see how the static catalog changes dynamically. As you can see, if we update the page, we will find this garden among the other ones. We can also try to add a new plant, for example, the aloe vera, to the demo IoT garden. With the Telegram bot, we are able to visualize the data about the sensors of our garden and to irrigate remotely the plants. When we start the bot, it automatically recognizes the users. With the status ID command, we are able to see the status of our devices and their relative ID. We can also check the values for the environmental parameters of our plants. In this case, we are checking plant 1. As you can see, there's no irrigation, so let's try to perform one remotely. We write the irrigate command, and it works. This is the Smart Garden project. Thank you for your attention.